All right, we're moving on to part 2 of finding the surface area and volume of triangular prisms. In this case, in this video, we're going to be looking at triangular prisms whose bases are isosceles triangles. So we have two examples to work through together. As in the first video, we want to start by drawing the base of the prism separate from the prism so that we can focus our attention entirely on it. So in this case, we know it's a triangular prism, which means the base is a triangle. And looking at the triangle, we can see that it's isosceles, meaning it has two congruent legs. According to this base of the triangle here, we can see that the isosceles segments are 15 units long, and the other side is 8 units long. The distance between those two triangular bases, the 11, represents our value of h, which will come into play when we find the surface area and volume of the solid. All right, so to find the area of this particular base, our capital B value, we need to determine the height of the triangle. Now we know that with an isosceles triangle, when we draw the height into the triangle, it divides this bottom segment into two congruent parts, which means since that segment was initially 8 units long, each portion will be 4 units long. We also know that that height is perpendicular to that opposite side. Therefore, we have a right triangle to deal with, which means the Pythagorean Theorem is going to come into play. All right, so 4 squared plus b squared, the other leg, is equal to this hypotenuse 15 squared. And here again, when it comes to solving this for that unknown leg length, we're going to take 15 squared minus 4 squared, and that gives us a value of 209, which means b squared, the squared value for that leg that we're looking for, this distance, is 209. 209 isn't a perfect square, so when I take the square root of that value, it's going to be some decimal. Because of that, and since I don't want to round any values until I get to the surface area and the volume, I'm going to leave that in that form, square root of 209. So that becomes this length here, which in the case of this triangle represents its height. So the area of that triangle, our capital B value, the area of the base, is 1/2 the length of the bottom segment, 8, times the height of that triangle, the square root of 209. And that's not a value that's going to be an exact value. It's not going to, well, it has an exact value, but it's not going to be a whole number. So in this case, 1/2 of 8 becomes 4, and the square root of 209 is still being multiplied by that 4. But for now, I'm just going to keep it in that exact form instead of making it a decimal form. So this is our value of capital B, the area of the base. Now we want to determine the perimeter of the base by adding all those side lengths together. We know that both of these segments have to have a length of 15, so that gives us a total of 30, plus the 8, 38 for a capital B value. Now it's time to find our surface area and our volume. Surface area of the prism, 2 times capital B, which is our 4 square root 209, 2 capital B plus the perimeter of the base times the height of the solid, 38 times the height of the solid, 11. You have to be cautious about confusing the height of this triangle with the height of the solid. When it comes to the surface area and the volume, make sure you're using the height of the solid, the distance between the bases, in this position. All right, so at this point, you're ready to go to a calculator, and you should be able to type all of that in at one time. In this case, we need 2 times 4 times the square root of 209. Because that opened a parenthesis when I started my square root, I'm going to have to close that parenthesis before I move on to the 38 times 11. So plus 38 times 11. 533.65. And in this case, we didn't have a label present in our diagram, so that will simply be units squared. Now let's look at the volume. Volume is the area of the base times the height of the solid. And we've already seen that the area of the base is 4 square root 209 times the height of the solid, 11. So there again, 4 square root 209, close the parenthesis if your calculator opens one. Not all calculators will. Equals 636.1 units cubed. And here again, we don't have a label present other than the expected units label. And that's how we find the surface area and volume when the base is an isosceles triangle. At this point, I would advise you to pause the video, attempt this second one on your own, and then come back and check yourself. Okay, so moving on to this second example, we can see that our base is yet again an isosceles triangle. In this case, the legs that are congruent are each 22 units long. And this other side, looking at the opposite base, is going to be 19 units long, which makes finding our perimeter a nice pretty whole number. All right, in order to find the area of this triangle, we have to determine the height of the triangle. Divide that 19 in half. Each of these will become 9.5 units long. So in our Pythagorean theorem, 9.5 squared plus b squared equals 22 squared. In this case, we get b squared equals 393.75. So b would be the square root of that value. Now, if this has a nice decimal version, when I take the square root of it, then I can simplify that to an actual simplified value. In this case, it doesn't have. It's one that would have to be rounded. So leave it in that form, just like we did the square root of 209 in the example above. All right, so then we're ready to find the area of the triangle. The area of the triangle is 1/2 that 19. You want to make sure you're using the entire segment there, times the vertical distance, which is the square root of 393.75. All right, so as before, half of 19 is 9.5, or 9.5, times the square root of 393.75. And that's our capital B value. Don't worry about making that into a decimal form because it's not your final product or answer. All right, perimeter of the base, 22 plus 22 plus 19. In this case, 63. And both of these are in units squared and units, since we have the absence of a label on the diagram itself. Now, the one thing we haven't done, we found our capital B and our capital P. We have not identified what the H value is. Remember, H is the distance between the triangle bases. So the distance between these two triangles would be this 35. So this represents our H value when it comes to finding the surface area and the volume, or the height of that particular prism. All right, so the surface area, 2 times the area of the base. Squeeze this in there here. Plus the perimeter of the base times the height, 35, that we have from the diagram. So typing that into the calculator, 2 times 9.5 times the square root of 393.75, close that parenthesis, plus 63 times 35. 2,582.02. Here again, absence of a label means we'll use units squared. All right, now for the volume. Volume is the area of the base times the height. So in this case, the area of the base times the height of the solid, 35, and some more button pushing on the calculator. Oops, helps if you press the right buttons, huh? Try that again. 6,597.84 units cubed since it's a volume. And that completes finding the surface area and volume of a triangular prism whose base is an isosceles triangle.